The last keynote that we have for today is a special one. Eric Chow, who's SSD General Manager at Huawei, where he's worked for over 17 years. Eric has an incredible technology leadership background. He's worked on infrastructure solutions, engineering, storage and data as a service, data management, data protection, and big data solutions. He has led the global customer support team, working with engineering and R&D to handle solution design, implementations, and maintenance. He has also spent time working on network technology research and core router testing, all important parts of the technology ecosystem. Just a moment about Huawei Technologies. It's truly a leading global provider of information and communication technology infrastructure and smart devices, with integrated solutions across 4 key domains: telecom, networks, IT, smart devices, and cloud services. They're committed to bringing digital to every person, every home, every business and organization, fully connected, intelligent world. They invest heavily in research, concentrating on technology breakthroughs that drive the world forward. With more than 180,000 employees and operating in more than 170 countries and regions, they currently serve 45 of the world's largest 50 telecom operators, supporting the communications needs of 1/3 of the world's population. Ladies and gentlemen, Eric Chow.
Thank you, Jay. Hello, good noon, everybody. Actually, I like this time slot is less crowded, and I'm the last of the keynotes, so maybe I can have more time, so have less pressure. Okay. This is our first keynote in Flash Summit. I hope it will not be the last one. In the future, we'll have more, be active in this event. Yes, Huawei is a well-known international company already for last 30 years. And in the SSD flash industry, actually, there are not so many people know about the Huawei Flash and Huawei SSD. Actually, we have been investing our R&D efforts on the SSD drive products for more than 13 years. We start from 2005, and then on 2007, we released our first PCIe SSD drive. So based on that, we built our flash-based server, flash-based storage, and also now Huawei Public Cloud is also using our products. So in the past 10 years, we get a lot of knowledge and experience in this industry. So today I would like to share some of them. So my topic today is going to talk about the application. You know, today the hardware upgrading is very well, and we get better and better hardware solutions. But still, there's a very big gap between the pure technology parameters and between this and the applications. So here you can see, when we, as Jay mentioned, most of my experience in the past is networking, okay? And I joined this flash products just 1.5 years ago. So when I joined this, when I talk with people always talk with me, oh, my drive is very good. So my IOPS is very good, my latency is good, but just few parameters. Everybody is talking the same. So just in maybe half hour, so I get I understand almost all the vendors, or what's their technology parameters. So, but still, when I talk with my customer, it's not clear to them, because their expectation is not just the LPS, not just the latency. That's simple. They know they have many, many issues. Yeah. For example, the performance, consistency, data recovery, the reliability, endurance, and the multi-vendors, and how to utilize that extending, say, the drive to the applications to make the application experience much better. So there's still many gaps. So, for example, one of the first one is about, for example, the consistency. Yeah, because of the WAF. Yeah, so the IOPS will have a very bad dropping when you have to do this garbage collection. Yes, and because of this, and the latency will become very worse. And another one, because for the interface limitation, because even now we upgrade from the SATA interface to SAS interface and to NVMe interface. Yeah, for example, in our latest version, we called ES3000 V5 product, we optimized our read and write bandwidth parameter in very high grade. The read, for example, the read bandwidth can reach 3.5 gigabyte per second, and the write, it's about 3.2 gigabyte per second. So even in the industry, it's a very good result. But you can see from the one terabyte to 16 terabyte, so the bandwidth there's no upgrade. Okay, so we can see the LPS per gigabyte is dropping down. Second, about the reliability. For example, the power loss protection is also is a headache. In the SLC phase, for example, for just a taxi, you only have one person inside. If you have an emergency happen, for one person to get out of the car, it's very easy. But if you go to the QLC, there are so many people. It's not that easy to get out of the car. So in a very short time, so you need a longer power loss protection. So this is also a very big challenge. And the SSD capacity today now is becoming bigger and bigger, and people like bigger capacity drives. But at the same time, you will find out if the drive failed or in any problem, so the data recovery will become more difficult. The endurance. From the SLC to the QLC, you can see the P cycling is going down very, very, very fast. So it's also a very big challenge to the system. At the same time, maybe you can say, okay, I save some of the cost, but you bring more risks. And the fail path of the drive, now because of the big capacity, now if, for example, it will 64 terabyte, okay, if the parts failed, it was damaged, so the cost is very, very high. Okay, for every customer, they don't want to be locked by single vendors. So even in Huawei, today we in HiSilicon, Huawei HiSilicon, we develop our in-house SSD. But in parallel, we are open to all the third-party vendors. So today we are playing, we are cooperating with the industry major player. So this is our strategy today and even for the future. So let's say if you use multi-vendors because every vendors, they have a different, let's say, the erasure block size and maybe something others. So it's very difficult to choose, decide how to choose the right RAID stripe size. Okay, this is one of the challenges, and then there's some others. People talk about open channel and many, it's a very hot, but still, let's say if we move in all the compute from the SSD to the host size, it's not smart. Because today the host size CPU is very busy. He needs offload, not overload. Okay, so it's a challenge. And the last one challenge I want to mention about, as I mentioned in the beginning, when we talk about the SSD with our customer, the application and the SSD, there's a very big gap. Oh, you have very good parameter, but it doesn't mapping directly to the application experience. So how to close this gap is very important. You can only, when you solve this problem, you can have the right dialogue with the customer and give them the right, help them to make the right decision. So this is a summarize. In the host managed SSD and the standard SSD, there are some of them can solve some of the problem, but there's no perfect solution for all of them. Yes. So because of this, we did many research and R&D invest. So we are trying to do optimization according to different use case. So, for example, for the standard SSD, we did something we think is very good. So, because standard SSD today is still, even in the coming 2 or 3 years, will still be the mainstream. Okay, so optimize the current generation of standard SSD. Even in the future, it's important to the business. So I'll give you an example about the smart multi-level scheduler. Because the workload is very complicated. There's a read, write, and some back-end operations like garbage collection and trim. Yeah, so how you can schedule all of this IOPS in the right way and make a very, good result. It's very complicated. So we design a multi-layer scheduler for all of this, and it's software defined. It's very flexible. Okay, so we can do it by a default, a typical configuration. So you can optimize them to a good result, or you can the host software. You can decide how to use this scheduler. Okay, so we have this result. So you can see the latency. The green one is we do the test in our lab. Okay, so the green one is Huawei drive after enable this multi-layer scheduler. And the upper level is the third-party drive. So you can see the difference. The consistency of the latency is very much different. Okay, so this is the technology can help the application to make a much better experience. Another one is when you work in the real world workload, it's difficult to set the priority manually. Okay? So it's very complicated, and by the knowledge we have, so we're trying to do something that let the drive can recognize the typical workload. So he will make the right schedule for the application. Okay? So we call this aware typical workload. Yeah. So this is the added value to the previous technology. So here we do the test on the math circle. So you can see the result. The typical read and read perform, because math circle is very sensitive to read. Okay? So the typical read performance by the drive, because of the limitation of a PCIe protocol, so there's no much room to improve. So our latest version compared to the V3 generation is about 10%. But by doing this smart workload processing, the database transaction performance can get 27% more. So that's the value of this technology. Yeah? So in the future, we are gradually to improve this technology, to let the drive can recognize more and more workload, to make a better optimization. It's a very interesting. Another example is about, people talk about multi-streams and many years. And actually we did this in the past already. Actually, 2017, we announced some of the products, storage products, using the multi-stream technologies and get very good results. And now we call it smart streams because the technology's explanation is easier. I say in the standard application use case, the different workload, the hot, warm, and cold data usually will be put into the same place, same block, or same page. So if you want to update one of the hot data, so the cold data or warm data will have to be moved. Yes? So in this case, it's very efficient. So by the smart streams, we can identify, okay, this is streams and the data should be moved more frequently than the others. So we separated them in the different page and blocks of the flash. So this can reduce a lot of inefficient move and read and erase and read and write, or write, especially write and erase. So this increases the endurance of the drive and also the performance. That's the 20% of the performance gain is based on some, let's say, mathematical workloads. But actually, we deploy this technology in Huawei enterprise storage. We get 48% more on the performance. So that's the power of this technology. So we think this is something even based on today's standard SSD, we can make something different. Okay? Yeah, this is our example. And we also working with some external customers, some hyperscalers. They implement these similar technologies and get very good results. Okay? Okay. We talk about open China. We think today, if you just push all the compute to the host, it's not right. It's not, that will not That's will not good for the system and for the applications. So we defined a P-log SSD. This technology is trying to, how to say, solve some of the problem. For example, we don't want the difference of the different flash, different windows, different generations, all of this difference will be transparent to the host. So we call it middleless. We don't want that to be aware by the host. Okay? So we solve all of this lower level issues that the host sides do what they should do. Okay? And by this technology, we can also support, let's say, flexible size. The different applications, the I/O size is quite different. So, okay, it's good. So you can define what you want. Yeah. And we can enable the byte level adjustable. Okay? It's also something very cool. And the bandwidth, okay, it's very good for the QoS. So if you need more bandwidth, okay, good. This is something you can do. You need less, okay. You just define it by your software, configure it. Yeah, so we have some evaluation in our lab. So that's the result. You can see in the left side, the WAF, when you put more and more workload, the WAF is almost flat. No change, no different. But for the traditional technology, it's different. And the latency, the IOPS, is also get very good result. So all of this technology, what I talked, and this technology is something can be, one plus one, it can make things much, much better, okay? The last one I want to talk about the cloud scenario, because today, in the cloud scenario, it's more complicated because the cluster becomes bigger and bigger. You are not only face the challenges when you working on the single node. So the networking becomes more important. It's more insensitive. From the application point of view, I just want to have a very good experience. Okay? So in this case, we only solve the problem on the drive. Doesn't help. We need to have an end-to-end view to see what else may jeopardize the latency, influence the application experience. So we also have NIC solution. Actually, it's similar as SSD. We have SSD in-house SSD. We also have in-house NIC, smart NIC solution. So this is the example. When the cluster of the cloud storage is being bigger and bigger, you need more networking connections. So when the connections became very large number, so the RDMA protocol, the latency is going to become worse. The yellow one you can see. And so in this case, you need a mechanism, a solution to manage the latency. This is what we have done. So we define a latency mechanism to control the latency. So even when the cluster size become bigger and bigger to thousands level, the latency can still keep relatively flat. So in this case, the application experience will keep the same. This is very important in the cloud scenario. So here we have some use case and real implementation in the cloud. This will show you some details about the latency and then the IOPS. Yeah, it's something very cool because networking is my favorite area, and I personally love it very much. Yeah, so we see the value. We use both networking technology and the drive technology, put them together, and in the future, we will have more this kind of solution. As a system company and a cloud company, we're not just looking at the drive itself. We want to solve the problem by system view to give much better result. So, Huawei is a very big company, but my business unit is more focused on this hardware. So we continuously to have more and more innovations on hardware side to enable better application experience. We can have the core design between the ASIC, the components, and the system. And we provide a multiple solution for the, for example, for the standard SSD and also for the, more flexible host managed solution. So we can use those solutions for different applications. Okay, this is the last page. We provide a full stack of solution from the NICs, SSD, and chip, those components level, and we also have networking, switches, servers, and storages, and cloud, many solutions. So we would have glad to work with the industry. Yeah. Then go back to the subject of my slides. Application not just need more than IOPS and latency. I'm not just coming today here to show off, I did something good, but I'm also want the major purpose I'm come here is because today, if you only make a good, the hardware stronger, but the gap between the hardware and the application is still very big. So we would like to work more and more partners together to define something, define something from the application level. Yeah, okay, this kind of application, forget about the drive, IOPS, and latency. Define the application to different levels. Then we can try our best to provide, an application level benchmark. Okay, not just driver benchmark. So based on that benchmark, hardware vendor like us can do more, can give applications more contribution. Yeah, this is something we would like to cooperate with as many partners as possible. Yeah. In the cloud scenario, it's more, let's say, we work with many cloud operators, okay, including Huawei public cloud and third-party public clouds. But for the enterprise, traditional enterprise, there's still a huge market. For the government, for telecom, for the enterprise, there are many applications. How to optimize those applications in the better way by the SSD technology, by the networking technologies, we need partners. we are glad to work with those partners on the solution level to give back the result. Okay, that's all my presentation. Thank you.